All right, welcome back, Hononegah, Algebra 1. Today we're going to really get into factoring. So far we've done factor by grouping, and we've done factoring with the greatest common factor. And so now this is when really we start getting into a situation that when you start talking about factoring, you really start talking about factoring a trinomial. Okay, so we got x squared plus bx plus c. And so we're going to factor without a lead coefficient, and we'll get into that later when we actually get into a lead coefficient. So no lead coefficient. Uh, so let's do a little bit of a warm up. If it's already in factored form, how do we solve? We set the factors, so x being a factor out in front, and x minus 7 being a factor. So we've set the factors equal to 0 and solve. So again, the second one here, we have 2x plus 1 being a factor and 3x minus 4 being a factor. So again, set the factors equal to 0 and solve. So I'm going to add 4 to both sides and divide by 3. So again, if it is in factored form already, set the parentheses equal to 0. Now here's one of those things that I really want to talk about. Factor, it doesn't say solve. So if there's no equal sign, there's no 0, you don't need to solve. Okay, only do what the directions are asking you. So it says factor out the greatest common factor. So I'm looking for the highest number and or letter that I can take out of both. So I can divide both of them by 3, and I can take away 2 x's. So if I divide by 3 and take away 2 x's, I'm left with 1x plus 4. And so the next one, the GCF, the highest number that's divisible into both is 3. And so then I'm left with 9. Oh, my fault. I did not take the GCF. My bad. The highest number that I can take out of both is 9. Sorry about that. So I'd have 3x plus 2. So when I looked at it, I realized that I did not get the highest, the greatest common factor, that I merely got a common factor. So be careful there. Make sure you get the greatest one. All right, factoring trinomials with a of 1, meaning there's no lead coefficient, there's no number in front of the x squared. Here's the questions you will constantly ask. What multiplies to equal c, but also then adds up to equal b? So we're going to be and then we're going to be writing those factors into the parentheses. So it's going to be a constant situation of your times tables. Two things that multiply to be one number, but add to be another. So since there is no number in front, we're looking at the c value. The c value is 8. So I need two things that'll multiply to be positive 8, but then they got to add up to be positive 6. So positive 4 times positive 2. And yes, the symbols do matter, okay? So I need a positive 4 times a positive 2, that would equal 8, and add up to equal 6. Once you have established those two numbers, because there's no number in front, it becomes x plus 4 and x plus 2. You're coming up with two things that'll multiply now to be 8 and add up to be 4, or add up to be 6, sorry. And so these two numbers become the factors in the parenthesis. So I need two things that'll multiply to be 36, but they got to add up to be positive 13. So positive 9 times a positive 4. So I get x plus 9 and x plus 4. Now, you'll notice that it's positive 15 here, but it's negative 8 in the middle. So I need two things that'll multiply to be positive 15. And the only way to get a positive number is to take a positive times a positive or a negative times a negative. So in this case, I'm going to take a negative 3 times a negative 5. Negative 3 times negative 5 is positive 15 and adds up to negative 8. So again, that little saying that I kept saying earlier about two things that multiply to be one number but add to be another. So if the last number is positive, the only way to get a positive is to have a positive times a positive or a negative times a negative. So negative 3 times negative 3 is positive 9, but it adds up to negative 6. So again, if your last number is positive, your C value is positive, the only way to do that is if you have a positive times a positive or a negative times a negative. Well, then the next question is going to pop up here is what happens if the last number is negative? The only way to get a negative is one of them has to be positive and one of them has to be negative. So that's the only way to get multiply to get to a negative. So now, if I had a negative 7 times a positive 1, then those two numbers will multiply to be negative 7 and add up to the b term, add up to negative 6. And so then I just need to merely write that down as its two factors. So I need two things that'll multiply to be negative 16. So again, I need a positive and a negative. That'll add up to positive 6. And once I have established those two, now it's a matter of writing them as factors. So this is how to factor a trinomial in which there's no number in front. Now, how do I solve this? 1, make sure it equals 0. 2, factor it. And then 3, set the factors equal to 0. So this is not new. This is exactly what we did previously, except now what we are trying to factor is a trinomial. Forget about the equals 0 part for a minute. Two things that will multiply to be 63, but add up to negative 16. And so again, those of you that may have struggled on your times tables, this is really going to come back to haunt you. Please talk to your teacher if you are somebody who struggles with their times tables about the possibility of a times table chart. So now to write these as factors. Now the next step is to solve. Once it is in factored form, so I did the factoring part now. Once it is in factored form, set the factors equal to 0 and solve. Next one, I'm trying to get a negative 4. Well, the only way to get a negative 4 is one is positive as one is negative. So positive 4 times a negative 1 would get you a positive 3. Once I have it in factored form, set the factors equal to 0 and solve. It doesn't equal 0 to start with. So now I got to do a little bit of prep work. I need to add 27 to both sides so that it equals 0. I see it's a trinomial with no number in front, so I need factors of 27. That'll add up to 12. I then will write those as factors, and then I will set the factors equal to 0 in order to solve. Again, this does not equal 0, and this is a little bit trickier. When I add 6x to both sides, the order really does matter. You need to write it in standard form. So the x squared would come first, the 6x would come second, and the negative 7 would come last. Now, two things that multiply would be a negative. Remember, the only way to get a negative is a positive and a negative, and 7 times 1. So now, writing the factors, because it's now asking me also to solve, I set those factors equal to 0 and solve. A farmer plants a rectangular pumpkin patch in the northeast corner of a square lot. The area of the pumpkin patch is 600 square meters. What is the area of the square plot? So now, I don't know this. I just want to find out what this area is. Now let's look at this. If that's 40 and this is 30, then this little side of this would be 30 plus s. Let me try this again. S minus 30. I spoke incorrectly there. So the whole side minus 30. And this side up here then would be S minus 40. So I have S minus 40 times S minus 30 equaling 600. So they told me that the area of the pumpkin patch, all right, so this is that's a horrible looking pumpkin patch is 600. So I'm going to FOIL this out. S squared minus 30s minus 40s plus 1200 Combine like terms. Subtract 600 so that I get everything equaling 0. Now, those of you may struggle a little bit on your times table. We'll need to probably do a little bit of a guess and check or a chart. Here's what I mean by a chart. I have 600 that I'm trying to come up with two numbers that'll multiply. Start with 1, and then divide by 2, then divide by 3, then divide by 4. I didn't 125. Then divide by 5. 126. 7. 8. I don't have it here in front of me. Let me wait 1 second here. 8 and 75. So I'm getting closer and closer. 600 divide by 9. 10 times 60. There it is. Okay, so I found the one that I'm looking for that multiplies to be 600, but also adds up to be 70. So a negative 10 and a negative 60. So S minus 10, S minus 60. So then set the factors equal to 0, and I get 60 and 10. Now, let's talk about this just a little bit. Can this side really be 10? Is that even possible? So if I plugged it in and I'm looking at this particular, if I put 10 in, wouldn't this be a side of negative 30? And this would be a side of negative 20? And you can't have a dimension of a something to be negative. But I can put in 60. 60 minus 40 would be 20. And 60 minus 30 would be 30. And so this plot is a 20 by 30 pumpkin patch. Your homework assignment tonight, going back to the first page, is page 389. Please make sure you talk to your teacher. This is really the beginning of some more complicated factoring. So please make sure that you are working on this. And if you have questions, talk to your teacher. And good luck.